Welcome back, everybody. Today, we're diving into something that's kind of the backbone of all the software you use every day, even if you've never actually written any code yourself.
Yeah.
We're talking about unit testing,
Ooh, unit test.
and our mission today is to really equip you to understand not just what it is, but why it is so crucial and how it actually works.
Yeah, it's funny. Unit testing, it's one of those things. It's actually even more than just catching bugs. It's about building better software right from the start, like from the ground up.
Okay, I'm intrigued. What makes it so powerful?
Well, imagine you're building a house. Would you wait till the whole thing is built before you checked if the foundation was any good?
No, definitely not. You'd want to catch those problems early on.
Exactly. And unit testing is kind of like that. It's like inspecting every brick and beam before you even think about assembling the whole house. It's about verifying each individual piece of your software works flawlessly before you start integrating it with all the other parts.
So if we think of a complex software application as our house, what would a unit be in this context?
A unit is really the smallest testable part of an application. It could be a single function, a method, or even a class. Kind of depends on the programming language and how the software is designed, but the key thing is that it's a self-contained piece of code with a specific purpose.
So let's say, for example, we're building a calculator app. Would a unit be something like the addition function?
Exactly. You got it. You would write a unit test specifically for that addition function, just to make sure that it consistently spits out the correct sum no matter what input you give it. And you wouldn't just test it with like 2 plus 2. You would try all sorts of different combinations, edge cases like negative numbers or even really, really big numbers, just to make sure it's super
It
robust.
sounds incredibly thorough and systematic.
It is. And this kind of brings us to the why. I mean, think about using an app that's constantly crashing or giving you the wrong answers.
Oh, so frustrating.
Super frustrating. Unit testing helps prevent all that by catching those errors early on when they're much easier and way cheaper to fix.
So it's like having a safety net kind of built into the entire development process.
You got it. Exactly. And, the benefits, they actually go way beyond just preventing those pesky bugs. Unit testing, it forces developers to think hard about how their code's actually going to be used. This often actually leads to much better design. It encourages what we call modularity, meaning the code is structured in a way that makes it super easy to understand, to maintain, and to modify later on down the line.
So it's not just about catching errors, it's about actually improving the entire structure and quality of the whole code base.
Absolutely. It even acts like a form of living documentation. When you have a nice, comprehensive suite of unit tests, anyone can look at them and instantly understand what each bit of code is supposed to do and how it behaves in different situations. This is incredibly valuable when you have new developers joining a team, or even when you're revisiting some code that was written ages ago.
So we've seen how unit testing saves time, saves money, prevents a lot of frustration in the long run, and even leads to much better code design. But how does it actually work in practice? Let's demystify the how.
So, at its core, unit testing follows a pretty simple three-step process: arrange, act, assert. Let's break it down with a real-world example. Imagine we're testing a function that calculates the area of a rectangle.
Okay, I can picture that.
All right, so in the arrange step, we set up the scene. We define the width and height of our rectangle. Let's say 5 and 10.
Okay, so we're providing the input for our function.
Right. And this is reflected in the code itself.
Okay.
So this code snippet, what it does is it shows how we create the variables for our test case. We assign the values, 5 and 10, to represent the width and height of the rectangle.
So this is setting the stage for the actual test.
Precisely. Next comes the act step, where we actually run the code that we're testing. In this case, we would call a function to calculate the area using the width and height that we defined earlier.
So the code's making its calculation based on the input we've given it, and then what?
Then comes the exciting part, the assert step. This is where we check the results. We know that the area of a 5 by 10 rectangle should be 50, right?
Right, of course, 5 times 10.
So we assert, or we declare in the code, that the result of the calculation should equal 50.
We're checking if the output matches what we expect.
Exactly. If it does, the test passes. Hooray. But if it doesn't, the test fails. And that tells us that we need to go back, investigate, and fix something in the code.
This makes perfect sense to me. It's a really clear, systematic way to make sure that the code's doing what it's supposed to do. But isn't this a ton of work for developers to do manually for every single piece of code?
You're absolutely right. Doing it manually would be incredibly tedious and time-consuming. And that is where testing frameworks swoop in to save the day.
Okay, tell me more about these frameworks.
Well, think of them as specialized toolkits that automate the entire process of writing, running, and analyzing unit tests. They provide all these pre-built functions to check for various conditions, they organize your tests, and they generate reports that highlight any failures.
So they make the whole process much more efficient and manageable.
Absolutely. And, there are different frameworks out there that cater to different programming languages, and they all have their own unique strengths. Junit is super popular for Java, Nunit is big for .NET languages, and then you have PyTest for Python, just to name a few.
So choosing the right framework depends on the specific tools and technologies being used for a given project.
Exactly. But the cool thing is the underlying principles, they remain the same. These frameworks streamline unit testing. They make it an absolutely integral part of the development workflow.
This sounds like a really powerful combination of process and tools, but I'm curious, can you give us a real-world example of how unit testing has actually made a difference in a real project?
Absolutely, I can. Let me tell you about a financial software company that was developing a new online banking platform. So this financial software company, right, they were building this whole new online banking platform.
Oh, wow.
Yeah, and you can imagine the stakes there.
Yeah.
Like any bug could have had some pretty disastrous consequences.
Absolutely, yeah. Financial software has to be super reliable.
Yeah, and they really understood that. They were totally committed to this rigorous unit testing, making sure that even the smallest functions were thoroughly tested.
Wow.
Yeah, things like calculating interest, transferring funds between accounts, even just generating those account statements, like all those little things, all broken down and individually tested.
It sounds like they weren't taking any chances at all.
Yeah, not a single one. And this actually ended up paying off hugely for them when they decided to refactor their code base.
Refactor, sorry for those of us who aren't familiar with that term.
Oh, yeah, of course.
Yeah.
Refactoring basically means you're restructuring the code without changing how it works on the outside. Think of it kind of like renovating a house. You're improving the internal structure and organization, but you're not changing how the house looks from the outside.
So making the code cleaner and more efficient under the hood.
Exactly.
Hmm.
But just like with any major renovation, refactoring can sometimes introduce these unexpected problems.
Oh, okay.
And that's really where their super comprehensive unit tests prove to be so valuable.
They acted like a safety net during the whole process.
Exactly. Yeah.
Yeah.
So after each change they made, they would run their entire suite of unit tests. And if any of those tests failed, boom, they knew right away that they had introduced a bug. And they could pinpoint exactly where it was and fix it immediately.
Oh, wow. So the unit tests were basically like an early warning system, preventing those bugs from sneaking into the final product.
Exactly. And this saved them countless hours of debugging and potential financial disasters. Down the line, they were able to confidently release this new platform, knowing that it was built on this super solid foundation of well-tested code.
This story really highlights how unit testing can be valuable even beyond that initial development phase. It provides that ongoing protection as the software evolves.
Absolutely. It gives developers the confidence to make changes, improvements, without being terrified of breaking something that was working before.
It's like having a safety harness when you're working on a skyscraper. So we've talked about what unit testing is, why it's important, and how it works. But let's zoom out for a second. We've been using this analogy of building a house. If unit testing is like inspecting the bricks, what other types of inspections happen in the world of software development?
That's a great question. And just like a house needs more than just sturdy bricks, good software needs multiple levels of testing to ensure quality and reliability. Unit testing is really just the foundation.
So what are some of those other essential types of testing?
Well, once we've double-checked that all the individual units are working correctly on their own, we move on to integration testing. And this is where we check if different units can play nicely together. Like, remember our calculator app?
Yeah.
Integration testing would make sure that the addition function interacts correctly with the display function to show the right sum on the screen.
So making sure all the plumbing of the application is connected up properly.
Yeah, that's a great way to put it. And then comes system testing. This is looking at the entire system as a whole, from the user interface to the back-end databases, and making sure everything interacts seamlessly in a real-world environment.
Wow.
It's like taking the entire house for a test drive, making sure the plumbing and the electricity and all the appliances, they all work together the way they should.
And of course, we can't forget about the most important testers, the users themselves.
You got it. That's where acceptance testing comes in. This is where you get real users to actually interact with the software to make sure it truly meets their needs and expectations.
Oh, okay.
It's like having a family move into the house and making sure that it's comfy and functional for everyday living.
So while unit testing is that crucial foundation, it works best as part of a bigger, more comprehensive testing strategy.
Exactly. It's about layering these different types of testing on top of each other to create a really robust quality assurance process.
This has been super insightful, even for someone like me who doesn't actually write code. Understanding these concepts helps me appreciate just how much complexity and care goes into building good software.
I agree. And you know what? It empowers you to ask better questions and advocate for that well-tested, high-quality software.
Now, before we wrap up, I want to bring this back to our listeners. It's easy to get lost in all the technical details, but what does all this mean for someone who just uses software every day? What's in it for them?
So we've been really digging deep into this world of unit testing and how important it is for making software that we can actually rely on. But how does all this impact, the average person who's just using the software? What's in it for them?
Well, just think about the last time you used an app that was full of bugs or just crashed on you out of the blue.
Yeah. Yeah, it's
Mm.
frustrating, right? And it can even cost you time or lose data sometimes. Unit testing, when it's part of like a really solid testing plan, it's all about preventing those bad experiences.
So when I'm using an app and it's smooth and it's responsive and it just does what I expect it to do, that means that, good testing practices were probably followed.
Absolutely. Thorough testing, and that starts with unit testing. It leads to much higher quality software overall. It means you're going to encounter fewer bugs, it's going to be more stable, and honestly, the whole user experience is just going to be more enjoyable.
It's like the difference between driving a car that's well maintained and one that's constantly breaking down on you.
Yeah, that's a perfect analogy. And
Yeah.
just like a reliable car gives you that peace of mind, well-tested software gives you confidence that it's going to work the way it's supposed to.
But beyond just the user experience, are there other ways that unit testing is impacting us, even if we don't see it directly?
Oh yeah, definitely. Think about software that handles really sensitive information, like your bank accounts, medical records, online shopping transactions.
Hmm.
Rigorous testing is actually helping to protect that data by making sure the software is secure and less vulnerable to those nasty attacks.
So unit testing is playing a role in cybersecurity as well.
Yeah, it's a big part of the whole puzzle. When you test the security features and like the potential weaknesses of each little component, developers can actually build systems that are way more robust and resilient.
So it sounds like the effects of unit testing go way beyond what we initially realize.
It really does. And more businesses are starting to recognize this. When they invest in unit testing, they're basically investing in keeping their customers happy, in protecting their brand's reputation, and even their own bottom line.
It's a real ripple effect that starts with those tiny individual tests.
Exactly. And even though we don't often see this work happening in the background, its impact on our digital lives is actually really huge.
So the next time I'm downloading an app or using a website, I'll be thinking about all those invisible tests working behind the scenes to make sure everything runs smoothly.
I love that. And, and understanding all of these concepts, it makes you a more informed user. You can start to appreciate well-crafted software and make smarter choices about the apps and services that you use every day.
This has been a fantastic deep dive into the world of unit testing. We've learned what it is, why it's so important, how it works, and ultimately how it impacts all of us as users of technology.
It's been a pleasure, as always.
We want to leave you with this thought. Think about all the software you use every single day, your phone, your computer, your favorite apps and websites. And now imagine if none of it was properly tested.
Yikes.
Right. What a scary thought.
It'd be a world of constant frustration and errors and crashes and security risks.
Yeah.
Thankfully, because of unit testing and all those other important testing practices, we can avoid all that chaos and enjoy a digital world that's much more reliable, secure, and enjoyable.
That's a much nicer picture to think about. So thank you for joining us on this deep dive. We'll see you next time.